Welcome. So what I'd like to do is show you how to graph f of x equals tangent of x divided by 2. But before I do that, I want to go over what at least the parent graph looks like of tangent as well as our transformations. So first of all, let's kind of write down f of x equals a times tan of bx minus c plus d. Now that's all the possible transformations. A, B, C, and D are all the different ways that we can affect and transform our graph. But what about if I'm just giving f of x equals tangent of x? What exactly does that graph look like? Well, if I just do one initial period, okay, the tangent of x has two asymptotes at pi halves and negative pi halves, and the graph looks something like this. Okay? So that is what we call our parent graph. That is with no transformations. And this graph just keeps on repeating each other. Notice the distance is negative pi halves to pi halves, which would be the next one, which would be at 3 pi halves. And then the next distance would be pi halves, which would be at pi. And it looked like that. Okay? So notice the distance between my intercepts and the asymptotes is pi. Okay? So when we're looking at a graphing tangent, the first thing, or tangent or any trigonometric functions, we want to make sure we at least know what the parent graph looks like. But then we want to know what are transformations, okay? And the only thing we have changed in this is I have something inside my parentheses. So the only value that changes is our phase shift, which to determine our phase shift, all we do is take whatever's inside our parentheses and set it equal to 0. Well, when I solve for x, I get x equals 0. So that's not going to be changing anything. However, the next thing is the period. Now, the period for tangent and cotangent is pi divided by b, where b is the number that is multiplied in front of our x. So you can see here, you could say, oh, well, only a 1 is being multiplied. You're right. But that 1 is also being divided by 2. So therefore, it's really pi divided by 1/2. So to simplify that, I can multiply by my reciprocal, and I get 2 pi. So when the initial period, so you can see the initial period is pi, right? The initial period is pi. Now my initial period is 2 pi. So I can set up the exact same graph, just like I did over here, but rather than having the distance of my asymptotes from my new vertex at pi halves, I'm now going to make them at pi. And then, that's at pi. That's a period. That's 2 pi, right? So then the next one will be at 2 pi. Next one is at 3 pi. And remember, the period represents the distance between pretty much the intervals that the graph is going to repeat itself. So again, from negative pi to pi is 2 pi, and from pi to 3 pi is 2 pi. And that's the only thing that's affecting our graph. Again, the phase shift, we didn't shift the graph left or right at all. We're not moving the graph up or down by D. We're not reflecting it in any way by A. So that is how you graph tangent of x divided by 2. Thanks.